So in this video, we're going to be practicing looking at trig expression and being able to simplify them. So one of the things I want to mention is simplifying trig expression is a little bit of vague. I guess that's the best way to explain. So I'm going to give us a few boundaries to work with. The first thing I want to do is basically, given the trig expression, I want us to not have any quotients, meaning no fractions. So when we're simplifying, let's make sure we don't get any fractions for this sake. And another thing is we're going to do our best to try to simplify it where we get down to one trig expression, meaning notice how these two have two trig expression. There's a cosine and a tangent, whereas we are going to try to get it down to one trig function. Now I want to give a little disclaimer before I begin this video. I want to say that this video can be challenging for most students. The reason why is because this math that we're going to be doing is not going to feel mechanical, meaning it's not going to be me telling you a formula or a step-by-step tutorial on how to do a problem, because each situation is going to be unique in its own. And this will, as you progress as a math student, you will pick up on certain patterns and certain experiences that you will notice in the trig functions, and that will make you better at recognizing what to do in a certain situation. And so today I want you to say that, grab yourself a drink and just watch, and I'm going to explain you why I do the things that I do for each trig, and you will maybe realize the beauty of some of the concepts that you've learned in your algebra classes, and you'll recognize why we've learned them, because they bring us these skills that allow us to manipulate something that's more complex. I know right now I'm sounding very, spiritual or poetic, but what I want to get down to is that we are going to grapple with some of these problems, and there is no step-by-step instruction that I can give to you. All I can give to you is knowledge and experience, and to show you why I've done the things that I've done to solve the problem. So let's get started. All right, so for part A here, I have cosine times tangent, and I'm trying to get this down to one trig function, at least as a goal, if I can. So one of the things I notice is that cosine is really hard to manipulate. At least when I think about cosine is just very simple. But tangent, on the other hand, can be expressed in many different ways. And one of the ways that we've learned to express tangent is using the quotient identity. So if you look back on your first page here, tangent can be expressed as sine over cosine. Sorry for the weird, layout. I think it accidentally moved by writing. So tangent here can be also expressed as sine over cosine. So what I'm doing right now is I'm manipulating what I know about a trig function so that I can see if I can cancel out anything. Now cosine comes down, and cosine, because it's sitting next to tangent like that, I can assume that it's multiplying. So I can assume that these two are multiplying each other, and I have a fraction, and this one's not a fraction, so I can always make it a fraction if I put it over 1. That's what I've learned. And from here, I notice that the cosines are diagonal from each other, so whoopity-doo, I get to cancel those out, and so when I multiply straight across, I notice I just have a sine, right? Sine's on top, and technically I do have a 1 in the bottom, because when these cosines canceled, it just made them, anytime something cancels, you leave behind a 1. Because in this case, if you think about it, cosine divided by cosine is just 1, and so that's why we leave behind 1. So 1 times sine is sine, 1 times 1 is 1, so sine over 1 is just sine. And so I'm able to simplify this into just a nice, simple sine. And in this case here, what I did was I had to manipulate tangent. And so one of the things I want you to remember from this problem is that tangent can also be written as sine over cosine, and that might help you cancel out things. All right, so one thing that we've learned, but let's move on to the next problem. So taking in that experience, let's try to use that to our advantage. So I see tangent again, and it's being multiplied by cosecant. So I know that tangent can be expressed as sine over cosine. So maybe let's play the same game. Let's see if this works for a different problem. Now, cosecant, if I were to just write cosecant here, that might be a little bit less intuitive, because if I just wrote cosecant here, I can't cancel out with anything. So that might not be helpful. So what I could do is to write cosecant as a different way. And so when we look back, cosecant is the reciprocal to sine. So another way I can write cosecant is 1 over sine. And that helps me try to, simplify this further down. So I can write this as 1 over sine, and aha, I notice something. I notice that diagonally I have 2 sines. So I can cancel those out. And so I hope that you're starting to notice what I'm trying to do is change the way the trig expression is so that I can notice if I can cancel anything or try to manipulate them. So the sines cancel, so they're just left with a 1 left. So 1 times 1 is just 1 on the top that I have. And then cosine times 1 is just cosine on the bottom. Now, I can't leave my answer as a quotient or fraction because that's what the problem said I couldn't do. So I have to change this 1 over cosine into something else. Now, if I really think about it, 1 over cosine, I've seen that before. I think that's a reciprocal. It's a reciprocal of secant. And so I can really write this fraction as secant because secant is just 1 over cosine. And so do you see how I am playing with my, my trig expressions to see if I can manipulate it into something else? It's like I'm doing like a bippity boppity boo. It's like I'll change this to something else, even though it's still going to be the same value. So from here, I can't really do anything else because, secant is already as one term, so it's pretty simplified. All right, so moving on to part C here. So part C, I have a cosecant here and I have a cosine over cotangent. So lots of stuff going on. So the first thing I'm going to notice here is I have a cosecant, so maybe I can change cosecant into its reciprocal. And so I know that cosecant, it's right here to the side, I know that cosecant is really just 1 over sine. It's the reciprocal of sine. So all I've done is change this guy to 1 over sine. Bring it over, that's really just multiplying, so I'll bring that over. You don't have to write the multiplication, but it does comfort me a little bit. And I have a cosine on top, so I really can't change cosine. Cosine is one of those things that I don't change a lot. Cosine and sine is things that usually I keep the way it looks. But for the reciprocals and tangent and cotangent, I do try to change. Now, for cotangent, I think I could probably change cotangent. So when I'm looking at cotangent here, I could probably change that to its quotient identity. So if you guys remember, cotangent is cosine over sine. So instead of writing cotangent here, I'm going to write what it represents, because maybe it'll help me cancel out some of this sine and cosine that I have here. So I'm trying to manipulate everything into sine and cosine because that will make it a little bit more helpful with combining like terms or canceling out like terms. So I'm going to bring down this 1 over sine theta, and what I'm going to do is do this fraction to the side. So I have cosine that is being divided by cosine over sine. So whenever I'm dividing by a fraction, I have to flip this guy. So I'll keep the top cosine the same. So I'm keeping this guy the same since it's in the numerator. And this guy I'm going to flip. So this is now going to be sine over cosine because it is being divided. So I have to flip the fraction. And so if I multiply, because when we divide, we multiply by this reciprocal, I notice that the cosines are diagonal from each other, so they cancel. But I also notice that sines, even though these two are a little bit further away, these sines are diagonal from each other. This sine is in the top and this sine's in the bottom. So they will also cancel. So when things cancel, they leave behind a 1. So if I look at this as one big old fraction, this is 1 times 1 times 1. That means I have a 1 on the top. And 1 times 1 times 1 is still a 1. So, oh my goodness, I get a 1 that ends up being my answer. And I really can't simplify 1 any further than that. But notice how I went from all of this trig functions to 1 in a matter of being able to manipulate the trig values into its basic form, which is sine and cosine, and then noticing that I could cancel out more stuff. All right, so quite some valuable stuff here. One of the things that we utilize quite a bit when it comes to simplifying trig expression is this ability to divide by fraction. So we're utilizing those elementary and middle school and algebraic skills that we've learned before to help us out. All right, let's get into part D here. So for part D, we have secant over cosecant. So first off, I'm thinking, okay, I'm dividing these two, but let's try to get that, let's utilize that skill that we just learned and to manipulate secant and cosecant so that it's in terms of sine and cosine. So I know that secant is really, if I just write to the side here, I know that secant is 1 over cosine. And I know that cosecant is going to be, cosecant is 1 over sine, right? So if I know that to the side, that's the fundamental identities that we use, then I can say that this secant here is 1 over cosine theta. And because I'm dividing by cosecant, which is this fraction here, I'm going to have to flip this fraction anyways. So I'm going to write a multiplication sign, and I'm going to go ahead and flip this fraction. So that's going to be sine over 1. So let me just replay that again. Essentially what I did was I took secant, which is 1 over cosine, and because I'm dividing it by cosecant, which is 1 over sine, I went ahead and just flipped this and multiplying it to the top. So when I do this, I just multiply straight across. So 1 times sine is just going to be sine theta, and my bottom's going to end up being cosine. And when I look at this, it's still a fraction, and I need to manipulate it to something that's not a fraction. But what I notice is I have a sine in the top, cosine in the bottom. Well, something that's sine over cosine is tangent. So using the quotient identity again, I notice that this is a representation of tangent, and now I'm down to 1 trig function. All right, so let's get into the next one here. We have cosecant here. So a lot of ways to play out this. We could distribute this cosecant in, but one of the things I notice is this one is a squared. So the only time I've noticed anything that's squared is when we use the Pythagorean identity. So the Pythagorean identities have squared trig values. And what I noticed is that we had a cosine trig value. So perhaps I can use this Pythagorean identity to help us out. So what I'm going to do is copy this Pythagorean identity, sine squared plus cosine squared equals 1, and kind of play with what we have. So I'm just going to write it to the side for a moment and just start to think. So I'm going to write Pythagorean identity, or I'll just write ID here. So sine squared plus cosine squared. So what I notice is this is 1 minus cosine squared. And the thing is, I can make that happen if I move this cosine over. Like in mathematics, we've learned that if I just subtract something over, right, I can create that. And so this would cancel. So sine squared would come down. And this would end up being 1 minus cosine squared. Well, I just created my own identity in a way, right? I just utilized the Pythagorean identity. I moved over the cosine. And what I notice is that this here is equivalent to what I have. And so because I noticed that this was a cosine squared, I used the Pythagorean identity to see if I can match that. And I can. So if I subtract the cosine square over, that means 1 minus cosine squared is actually sine. So what I can claim here is that this piece right here is actually sine squared. And if I bring down this piece, which is cosecant, notice how much I've transformed this problem. I've just taken the parentheses, what's in the parentheses, and just condensed it to sine squared because I realized using the Pythagorean theorem, that's what it should equal. And so from here, I'm like, oh, well, cosecant is actually just 1 over sine, right? Cosecant is the reciprocal of sine, and this is sine squared. And if I'm multiplying by a fraction, then I'll notice, oh, then the sine cancels on the bottom, and I can take away one of the signs on the top. So I'm really just left with 1 times sine, which this sine is to the first power, so it's just 1 sine that's left. And the bottom ends up just being a 1. So this ends up just being sine. All right, and that's it. There's not much else that I can do because I'm just left with sine, one trig term. All right, so let's move on to f. Now with f here, I notice there are 2 parentheses, and I could go in and just change what secant is, but one of the things I notice is that there are 2 parentheses, and secant, if I were to change it, it'd just be 1 over cosine. And if I have 1 over cosine minus 1, I really can't do much with that. So instead, I want to think about this problem is, because there are 2 parentheses, maybe this is like a foiling problem, like what we done in our warm-up. And so if I were to FOIL it, let's see what happens. So if I multiply the secant, secant times secant is secant squared. Kind of like when you have x like this. X times x is x squared, and x times -1 is 1x. Kind of like that. That's what I'm doing here. Secant times +1 is just going to be a positive secant. If I multiply -1 with secant, that's just going to be a negative secant. And -1 times +1 is -1. So what I noticed when I did this is that the middle terms cancel because they're both secants, but they're opposite signs. So that's kind of nice. So I can wipe out the middle, and now I just have secant squared minus 1. So the 1 to the side I just brought down. And so when I look at this, I'm like, secant squared, that looks familiar. If I look at my trig identities, the Pythagorean has a secant squared. It's this one here. And so it says tangent plus 1 is secant squared. So I'm going to copy that and see if I can manipulate it to my advantage. So writing it to the side here. So the Pythagorean identity that I'm looking at is the one with tangent and secant. So I notice that this secant has a -1. So let's see, if I subtract this one over, maybe I can figure out what I can replace this with. So that cancels, tangent square comes down, and this is secant squared minus 1. And so I just made secant squared minus 1 right here. Turns out secant squared minus 1 is equivalent to tangent. So I can replace this guy with tangent. Well, that's kind of sweet because now I only have it written as 1 term, whereas this had 2 terms. So I think I'm good here. I think I'm done simplifying. I got this down to 1 trig function. So I want to mention about this problem because it does have a lot of skills that played out. One of the things is that oftentimes when you have 2 sets of parentheses, foiling something out can be really helpful, especially if you notice that both of these parentheses are very similar, but they're opposite signs. Anytime two parentheses have opposite signs, what happens is that the middle terms cancel out. And that just has to do is because they're opposite signs of each other. Another thing is that using the other Pythagorean identities to help you cancel out or replace stuff can be really helpful. All right, let's get down to our last 2 problems. So for part G here, we have sine squared times tangent squared plus 1. And so immediately I'm starting to recognize that I see a tangent squared plus 1, and that makes me think of, wow, maybe that's a Pythagorean identity. So we were talking about Pythagorean identities before. The one we just looked at was 1 plus tangent squared equals secant squared. And even though these are not in the same order as what I have here, I can still say that this still equals secant squared. So even though they're out of order, remember that when it comes to addition, the order doesn't matter for addition. Tangent squared plus 1 is still going to lead us to secant squared. And so now I'm going to just bring down sine squared. And these 2 are being multiplied. So again, whenever you're given something to multiply or manipulate, I would go ahead and try to get it to its sine and cosine version. So what I'm going to do is take this secant and change it to 1 over cosine. And because this cosine here is squared, that means you have to square the top and the bottom. But if I square 1, it's just 1. But if I square the bottom, I get cosine squared. So make sure it's a cosine squared in the bottom. Bringing down the sine squared, I have to multiply sine with this fraction. So if it helps, definitely put this over 1 if it helps you recognize you have to multiply straight across. So if I multiply straight across, I have sine squared on top and cosine squared on the bottom. Ooh, did I mess up? Yeah, I should have been using x's. I keep moving back from x's and thetas. Gets a little confusing for me, my bad. So these are just x's. And the next thing I notice is that I have sine on the top and cosine on the bottom, and they're both squared. And so I'm thinking, then I probably have a tangent here. And this is not just any tangent, it's tangent squared, because both the top and bottom are squared, so this is going to be a tangent squared. And now I have finally written it as one trig function. So what I did there was use the quotient identity. Oh, no wonder this is so dark, it's a highlighter, my bad. So using the quotient identity sine over cosine, I was able to recognize that I can simplify that further down. And so that helps me get rid of these quotients or these fractions. All right, last problem here. We have a cosecant squared minus 1 over cosine squared. So anytime I'm noticing a square, I'm thinking back to Pythagorean identity. So I don't think we've used this Pythagorean identity yet. It's our third one. But let's also highlight this one here. We have the one that's the furthest to the side, which is 1 plus cotangent squared equals cosecant. So I'm using this one because I noticed there's a cosecant squared. So one of the Pythagorean identity has a cosecant squared. And what I notice is the one I have has a minus 1 next to it. Well, for me, I have a plus 1 here. If I subtract it to the other side, I can get rid of this. Cotangent squared comes down, and cosecant would be subtracted by 1 on the other side. And so what I notice is that this here is the same thing that I have. So I can replace this here with cotangent squared. Oops, with cotangent squared. So that's kind of nice. So I can replace all of that with one simple trig function. So that's what I'm going to do first, is just replace that. And then let's see, what could I do next? The next thing I notice is that I have a cosine on the bottom, so there's not much I can do with that. But cotangent on the top, I can switch that. So cotangent is really, if we think about it for a moment to the side, cotangent is just cosine over sine. But for us, these are going to be squared because we have a cotangent squared. And I'm also dividing that by cosine. So if this is a fraction that I have on the top, let me rewrite that on the bottom. So I have cosine squared over sine squared. So this guy is just representing cotangent squared. And I'm dividing it by cosine squared. So if I wrote this cosine squared as a fraction, then that helps me recognize that I have to flip this fraction when I'm dividing. So I'm going to flip it and make it 1 over cosine. So what I did was I wrote cotangent as its cosine and sine form. And then I divided it by cosine squared. So I had to write it as 1 over cosine in order to divide. From there, I can see that the diagonals cancel. And I'm left with 1 over sine squared. But I can't leave my answer as a quotient or a fraction, so I need to change 1 over sine squared. Now, 1 over sine squared is like the reciprocal identity to cosecant. So I can really write this as cosecant, since cosecant is the reciprocal to sine. So I have really cosecant squared, and that can be my final answer since it's one trig function now. So I hope you guys found this examples to be helpful. And like I said, these examples are just helping you build the knowledge that you've already have accumulated over time and utilize them in ways that you've never thought them to be played out. Like I said, each problem was unique, but what I was doing is kind of building the skills together and seeing what could I manipulate, What could I do maybe to multiply the fraction or divide the fraction, and seeing what could cancel. And so a lot of key things I want you to take away from this video is changing tangents or cotangents or reciprocals into terms of sine and cosine. Bringing them into sine and cosine helps you tremendously to help you cancel out things. So that's definitely number one key thing. A second thing is whenever you have factors, seeing if you can multiply out to cancel out anything could be helpful. Anytime you notice that, and I guess tip 3 is anytime you notice there is a square, then utilizing those Pythagorean theorems might be super helpful as well, and changing them using the Pythagorean identities. All right, so I hope you guys found this video helpful. I'll see you guys in the next video. Bye, guys.